We're going to be taking a look at the greenhouse effect today. So we have a very elaborate model set up of the greenhouse effect. We're going to be looking at what happens as sunlight, which is represented by my big lamp here, shines down on the ground, which is represented by some black construction paper at the bottom, so that we are able to absorb all the light energy from the sun. It's going to convert it to infrared radiation. That infrared radiation will rise off the surface and heat up the air inside our fish tank. Now, you'll notice that our fish tank is open. Why? Because the atmosphere is an open system. A lot of greenhouse effect models close your model off, and as a result, you just get the same air being heated over and over again through convection. We don't want to heat our air through convection, we want to heat our air through radiation, which more accurately models what happens in the atmosphere as greenhouse gases absorb infrared radiation from the surface of the Earth and continuously heat up. So, at the bottom is 3 different thermometers. So, you probably can't see from the view of the camera, there's a thermometer on the back that's taking the temperature around this area right here, which is about halfway up the level of the fish tank. There's a thermometer in the front here which is taking the temperature right from the bottom surface, and there's a thermometer up here. This thermometer up here represents our control. Ideally, if we fill a fish tank with carbon dioxide, what should happen is that we should get, and I'm just going to start this now, what should happen is we should get our fish tank filled with carbon dioxide, and because carbon dioxide is heavier than air, as it rises above the rim of the fish tank, it's not going to continuously filter up in a column, but most of the excess carbon dioxide will fall off to the side. So the air that's going to be directly above here may be a little enriched in carbon dioxide, but should more accurately represent the level of carbon dioxide that we have in the fish tank right now. Okay? The temperature probes in the middle and the bottom of the fish tank represent the temperature in an enriched carbon dioxide or an enhanced greenhouse atmosphere. The reason we have 2 temperature probes is because in order to generate some carbon dioxide, we're going to use dry ice, which is going to have a chilling effect on the bottom of the fish tank. It's going to have a chilling effect on the entire fish tank, but we want to just be able to mark that and recognize that how much it's cooling the inside of the fish tank. So we've set up an extra temperature probe here, and we'll see that in the results as we get into it. Okay? So what I'm going to do right now is I'm going to turn on the sun. I'm not going to enhance the carbon dioxide at all right now, but I am going to turn on the sun. And if you're looking at the graph we continuously put in the side of this video, if you're looking at the graph of the temperature, is it starting to come through at all? Yeah, it is. Okay, we're good. So if you're looking at the graph of the temperature, you'll notice that there is already some variation in the 3 temperatures, just purely based on where they are in the fish tank. But we're going to see what happens to those 3 temperatures as the ground heats up and radiation is able to leave the ground and then come up and heat those thermometers just a little bit. We're not going to be looking at huge amounts of heat increase here. It's not like we're putting this on a hot plate. We're just seeing what happens through the process of infrared radiation leaving the surface of the Earth and heating those things up. Now you'll notice that there's a pane of glass here. The reason for that is this is a 250 watt light bulb, which if you remember from grade 9 science, you know 250 watts is a lot of power, and a regular incandescent light bulb generates a lot of its power as heat. So we want to stop infrared radiation from coming through the glass, so I put the glass there as a little bit of an insulator. I can still feel some infrared radiation, but it blocks a fair amount of that infrared radiation from coming down. We want to represent the fact that our atmosphere allows visible light to come through but stops infrared radiation, because the greenhouse gases absorb infrared radiation. So it stops the infrared radiation from coming all the way to the surface of the Earth, and the warming that we feel near the surface of the Earth is purely a result of the infrared radiation leaving the surface of the Earth after it's been heated by visible light. Okay? So hopefully our pane of glass, if you remember from the optics unit, we showed that infrared light will not go through glass, or most wavelengths of infrared light won't go through glass. So our heat should be mostly stopped by the pane of glass. Lots of ways that we could generate carbon dioxide. I could blow in the fish tank for a long time. We could have a neutralization reaction. So if we used a carbonate neutralization like baking soda and vinegar, we could get a lot of carbon dioxide. That'd make a big mess in my fish tank. And none of those methods are nearly as fun as dry ice. Okay? The extra advantage of dry ice, if you're going to be creating a scientific model or a scientific experiment, it's always helpful if you can exaggerate or emphasize your dependent variable. So our dependent variable here is going to be temperature, obviously. So I want to start from a cooler environment, if I can, rather than having a hot environment. Like I could have created carbon dioxide by having a fire in here, but that would have raised the temperature inside my fish tank so much that when I turn the light on, I wouldn't notice any difference, regardless of how much carbon dioxide I had. So if I have some dry ice, that actually brings the temperature inside my model down a little bit, and then hopefully we can notice even more change as a result of something as minor and seemingly insignificant as a light source. Okay? So I'm going to start generating a little bit of extra carbon dioxide. I'm hoping that we've got a few minutes of data there that we'll see in the end. I just always like to pause for that part because it's my favorite. Okay. So what you're hearing is, it's like lobsters in a pot. No, it's not lobsters in a pot. It's the metal screeching as parts of the metal at this end cool faster than the parts of the metal down here, and the metal's literally crying itself apart. So what we see right away is not actually carbon dioxide. What you're seeing in here is fog. So our air in our room here had a lot of moisture in it. As we cool that air, so as individual molecules of carbon dioxide leave the dry ice, I can't even talk over it, it's so loud. As individual molecules of carbon dioxide leave the dry ice, they come out of my beaker and they start to move around the fish tank. All the water molecules around them will condense onto that cold molecule of carbon dioxide. Okay, so even though we're not actually looking at carbon dioxide, we can't see carbon dioxide, it is a clear, colorless, odorless gas, we can detect its effects. So we can see where the cold carbon dioxide is having an effect on the water vapor around it, causing it to condense, causing it to turn into fog or a cloud. And we can see that that cloud is slowly coming up to the edge of the fish tank. The fact that the carbon dioxide will not reach up to the level of the control probe here, which is testing the regular environment of the room, or the concentration of carbon dioxide in the rest of the room. Now, there's always a question, is this really in fact carbon dioxide? So we do have a carbon dioxide sensor that we can use to detect, and if we're looking at that later, we'll see that the level of carbon dioxide right now is set at about 53 parts per million. If I put it into the fish tank, we'll notice that that jumps right up. We're already at over 2,000 parts per million. So essentially we have like almost an exclusively carbon dioxide rich environment in the fish tank right now. Obviously there's still lots of water vapor in there, which is why we've got water. But any of the carbon dioxide, we didn't quite have enough. I don't think we're going to make it over the edge of the fish tank. But we can see that there's no carbon dioxide interacting with the top probe here. So that should still remain as our control probe. Okay. And we've definitely seen a spike up in temperature. At that, can you see that better now? Okay, so if we are looking at that, we see that right away our temperature was gradually increasing in all three of those temperature probes. The red here is actually the temperature probe at the top. The blue is the temperature probe in the middle. The green is the temperature probe at the bottom. So the temperature we noticed was climbing. At some point in here is where I added the dry ice, and that's why we noticed that these two dropped. Okay, so the green one here definitely dropped a lot because it's down at the bottom. The red one didn't really change, so it wasn't really affected by the dry ice very much. The blue one started to drop, or at least level out, and now it seems to continue, it still be climbing, which is exactly what we thought. We can see that our carbon dioxide is now at about 100,000 parts per million, which is essentially, what's that, 10% of the atmosphere in there is carbon dioxide. So I'm just going to give this carbon dioxide sensor a break here. We'll move it off to the side, and hopefully that'll come back down to a more sensible level. But what we want to know is, are the temperatures, and you can see that this one is now starting to rebound a little bit now that we're no longer actively cooling the bottom of the fish tank. The red here is still continuing to climb a little bit. It started out a little bit cooler, but it definitely has caught up, or it's started out a little bit cooler, but it's significantly cooler now than the other two that are in the middle of our carbon dioxide rich environment. Okay, so if we look inside the fish tank, it might look like our enhanced greenhouse environment has stopped. Most of the fog is gone. If I come over here and look a little closer, we've got a lot of condensation on the glass, but we can see right down in there, and most of that condensation, most of that fog has abated. So we can probably suspect that our carbon dioxide is also gone, but remember, the fog was just a visual result of the carbon dioxide cooling the air around it. We still have lots of carbon dioxide, so now that my sensor is back down at a normal level, my CO2 sensor, I'm going to drop that in just for another check to see if we still do have any carbon dioxide in the tank. And as you can see by the rapidly climbing number on the CO2 probe, there's still plenty of carbon dioxide in the fish tank. So we've still got an enhanced greenhouse environment. Now, Heisenberg's uncertainty principle tells us that the more we study something, the more we change it, right? And so every time I do anything over here near the fish tank, I'm changing my fish tank environment. I'm changing the CO2 because every time I even walk around it, I'm introducing air currents that's going to mix that CO2 up. So we are introducing a little bit of randomness just by virtue of being in the room with this test. We're back over 100,000 parts per million, so I'm going to give the CO2 sensor a break over here. Clearly we've still got lots of CO2 going on. But we can see from our three temperature probes that the red has totally plateaued. The blue and the green are both still climbing. That green, the bottom temperature, the one that was directly affected by the dry ice, that's still significantly cooler than the blue, but it's starting to catch up. So the one thing we know about the greenhouse effect is that it is vital for life on Earth. Okay? Anywhere else in the solar system that doesn't have a reasonable greenhouse effect, we know that the temperature variation between day and night can be extreme. So the greenhouse effect, as I mentioned, because the light here, the glass here is also representing our greenhouse gases, stops infrared light from coming down and actually keeps us a little bit cooler in the day. Okay? A lot of that infrared light gets absorbed higher in the atmosphere, whereas what we're seeing down here in the fish tank is the greenhouse gases absorbing infrared light that have left the surface and are closer to the surface. Okay? So the greenhouse effect helps keep us a little bit cooler during the day, but as we're going to see here, so we're just going to take a time stamp. Time is at 18.1 minutes. We're kind of right in the middle of our plot here, and I'm going to turn the temperature probe off, or the light source off. Okay, and we're going to see what happens at night. Theory tells us that at night the carbon dioxide should continue to retain a lot of that heat, because as radiation leaves one particle of carbon dioxide, it might interact with another particle of carbon dioxide and get reabsorbed there before leaving the Earth entirely and escaping off into space. So we're going to just watch what happens to our temperature probes after turning out the light there. We're still getting a little bit of radiation coming off the surface right now because the surface is still going to be warm, but after a minute or two that should start to cool down a little bit, and we'll see what happens to that temperature probe as we go. So we can see that down here where the condensation was thickest, okay, it's now been totally warmed. So we've obviously got like a temperature inversion down here where this area is warmer, then we have a cool area before we get to the warmer top, which is exactly what the temperature profiles are showing. We're going to be taking a look at the greenhouse effect today. So we have a very elaborate model set up of the greenhouse